Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Two Factor by Florian Klauser. And here are the rules. I'm gonna assume normal Sudoku rules because otherwise it just doesn't make any sense. Which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, which is a box. We also have digits do not repeat within cages. So these are killer cages, but they don't add to any sum. He's just using the there are no repeats in any cages part of the cages. I've always thought about this. Like if I were going to set puzzles, particularly killer Sudoku puzzles, I was going to use that aspect of there are no repeats. But yeah, so that's why I was kind of intrigued by this puzzle here. And finally, we have digits on a thermometer strictly increase in value as they move away from the bulb. So basically, you could have an example here, something like 3, 4, 6, and 8, and that would be valid because it's strictly increasing from the bulb to the tip. You could not have something like 3, 7, 6, and 8 because it's decreasing from the 7 to the 6, and that's not allowed. And those are all the rules. If you like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay. So we have a couple of 9-cell cages. That means we know these cells have to be exactly the same as these 3 cells. And these two... These 2 cells must be part of these 3. These 3 cells also are exactly the same as these 3 cells. This has 6 cells, 8 cells. These 2 cells have to be cannot be any of these. So in row 9, where can they be? They can't be any of these. They have to be the same as these 2 cells here. Which means in row 6, one of them is here and one of them is here. So similarly, we have these 2 cells, right? Which have to be the same as this and this. What does this mean? Wow. The only difference then, so these are the same shapes here as this. We just have an added difference here, and we have thermometers difference. What does that mean? I'm not really sure. This blue obviously cannot be any of these. It can't be here, so it can't be this. So this one, okay, so let's start marking this as letters. Maybe that'll be helpful. Let's mark this as D. D cannot be here, cannot be here, cannot be the pink cell because that matches one of these pink cells here. So D has to be one of these 2, and then it must be one of those 3. These 2 cannot be any of these 5. It cannot match the... Oh. Where are these 2 digits in row 8? They must match these. because they cannot be the pink. The pink matches these two. And it can't be here because they're in the same cage. So they must match these. But we don't know which ones. Interesting. And then they must match here, right? So similarly, these two must match this and that. This cannot be any of these, cannot match the yellow, so this must match one of these two. So the greens have to match specifically here and here. That's interesting. So if this were here, so one of these is D. The other one has to be one of these two, right? Or one of these three has to be one of these two. Hmm. Hmm. So what if this matches here? That means it has to be that one. Hmm. Medium gray has to be one of those three. D has to be one of these three and one of those two. Huh. Well, let's go through what I usually do with thermometers. The problem is these aren't very long thermometers, so it's not that helpful. This is 1 through 6, 2 through 7, 3 through 8, and 4 through 9. 1 through 6, 2 through 7, 3 through 8, and 4 through 9. 1 through 7, 2 through 8, 3 through 9. 1 through 7, 2 through 8, 3 through 9. 1 through 7, 2 through 8, 3 through 9. Okay, so this is a pink, which means one of those is that pink one. I don't think that's very helpful. Pink also, the other pink has to be one of these 3. That's interesting. And the other blue obviously has to be one of those 3 also. Hmm. Let's remove the numbers. That's not very helpful. It just clutters things up. Yeah, I think the key here is the logic between the shapes, essentially. The geometries. So, let's try to sort of map where these are. I'm going to start with A through I guess. A, B, C, D, E, F, G, H, and I. A has to match one of these two. F must match one of those two. Because where are these in row 8? They can't be any of these. They can't be any of these, so they must match those. So this is an AF pair. B or C have to be here and here. So this is a BC pair. This is D and E. F cannot be either. Okay, so this F, no, it's here. So this is some combination of G, H, and I. We got A, B, C, D, E, F. That just makes it too big. So we know one of G, H, or I is missing here. D and E have to be along here. So we know D and E are somewhere here. So this is some combination of DE with GH or I. That means F is over here. And it's some combination with GH or I. This is GH or I. Whichever ones that are missing here have to be here. F is here. And this is A and B or C. We know A is one of these 3, but we don't know which. Okay, so this combination is AF and G. We don't know which though. That means these have to be, we have one out of B or C here. D is definitely here. Okay. G cannot be here because it's in the same box as this. F can't be here. This is specifically H or I. Huh. Okay, that's good to know. So G still could be here. Oh, no, wait. G cannot be here. So G has to be one of these two, which means this cannot be G. That means this is not H and I, it's FG pair. Interesting. So this is AF and G also. Right, this must match here. F cannot, where is F? So A and, okay, so where are these digits in row 8? They can't be here, they can't be here. They must match these. So this is A and F. We're just marking it regularly. So A and F must match these two. That's A and F. A has to be here. F is here. F cannot be here. F cannot be here. So F has to be one of these two because it can't be here because of the cage. G cannot be any of these. Cannot be this. Cannot be the B or C because these match here. So G has to be one of these digits here. which means it cannot be here. It has to be here. So this is A, F, and G. I think then that also means this has to be A, F, and G here. Right? Because this digit has to be one of these. It cannot match this because it's in the same cage, so it must be one of these two. Again, these two must match these two because there's no other place. It can't be here because they're in the same box. Can't be here because they're in the same cage. So it must be these two. So these two match these two. Where can this be then? We know it's one of these two. It cannot match any of these. It must be one of these. So these are all A, F, and G, which means this is A, F, and G also. This cannot be F, obviously, so this is an AG pair, which forces this to be F. So this is F and that's F. This is an AG pair, so this cannot be A. F can't be here. F cannot be here, so F has to be one of these three. Since we know F is one of these three, F has to be one of these three. This can't be F, this is A, which makes this F. So this can no longer be A here. A has to be one of these two. A cannot be here, A cannot be here, A cannot be in the cage, so this must be A. Which means this can't be A, this is G, which means this can't be G, this is A. So this can't be A here. A is one of these two. That makes this G. Well, we already knew this was G. So it's A, G, and F. G cannot be here, and G cannot be in the cage. So G is also one of these three. We have H. Okay, yeah, so let's capitalize them to just make it distinct. G cannot be here. Therefore, this is G here. So this is A, F, or G, which means this cannot be the A, F, or G here, so it must match this one. So this is F or G. Right, one of these two is that one. The other one has to be here. That means this can't be A, F, or G. So the other A, F, or G is here. We're not sure which. F is in between. It's less than a digit and it's greater than a digit, but we don't know which one so far. A has to be one of these. F or G is this one. That means both FG cannot be here. Therefore, this must be an FG. Since this is FG, right? Because both of these can't be, because that would eliminate that would make 4 cells have to have 3 digits here. So one of these is FG. We have an FG here, which means that is no more FG in row 2. So this can't be FG. This must be then the other FG. Interesting. Huh. A is at least 4 larger than one of the FG, or 3 larger than one of the FGs. F cannot be here. F has to be, F has to be one of these two. Aha. Okay. So in box 5, we're looking for where the F can be. F can't be here. F can't be here because of F in the column and the row. Also, G has to be one of these 3 too. But F cannot be here because this is strictly less than this digit. So F has to be one of these two. Since F is one of these two, and F has to be in rows 5 and 6 in box 5 and rows 5 and 6 in box 6. That means F cannot be in rows 5 and 6 in box 4. So this cannot be F. This is G. This can't be F or G. This is A. This obviously can't be A or for G, so F has to be here. That means this can't be F. This is G. This can't be F or G. This is A, which makes that F. So this is A. This is F. That makes this G. That makes this an F. So this is F, G, A. Which means this can't be F. This is G. That makes that F. Which means this can't be F. This is G. This can't be G or A. So this is F, which makes that A. So G can no longer, F can't be here. F has to be here. G can't be here, so G has to be here. A cannot be here or here, so where's A and can't be here? A has to be here. Which means A is 4 less, it's at least 3 less than F. This can't be A, so this must be A here. So we should have all the A's, G's, and F's. Yes. Okay, so A has to be at least, so A is in the middle. A has to be 4, 5, or 6. Because it's at least 3 less than F. F is at least 7, 8, or 9. Oh, that's interesting. Okay, so then we're going to start. Okay, so let's. Okay, do we have any other information? Not particular. Okay, so this is D with B or C here. Sorry, D and E with B or C. Okay. That means this cannot be D or E. It's B, C, H, or I. Okay. F is smaller than another digit. So F can only be 7 or 8. Okay. That means, okay, so G. Okay, we're gonna. We're gonna mark these all with G in the corner so that we can actually see what these are. Same with the A's. And same with the F's. G has to be at least 1, 2, 3, 4. That means this is at least 4, 5, 6, and 7. This must be at least 7. That's 8. So this is 8 or 9, 7 or 8, 6 or 7, 5 or 6, 4, 5, 4, 5, 3, 4, 2, 3, 1, 2. G is greater than, I was going to say, G is greater than another digit. So this cannot be, that means G's are all 2's. So G's have to be 2's. That means this is 3, 4. All the A's must be 5's. That makes this 6, 7. All the F's must be 8's. And that makes this 9. So then we can remove all the letters for everything else. And just figure things out, right? So this is obviously 1, because it's less than 2. This is at minimum. So this 1 must be an H or I. So one of these is 1. Obviously that can't be 1, so this must be 1 here. Because these two match these two. Again, this was a H or I because none of these two match these two. Obviously, none of these could be here, so one had to be here. Cannot be here, so this is 1. So this is H, which means 1 has to be here. 1 cannot be here. Okay, what are the remaining digits in... I don't know. Let's try... Let's do here. That means... So since this is here... This cannot match this. Or here. So it must be here. Which means this matches here. Okay, so this is the same digit as that. So we're going to try to match the other stuff, right? Okay, so we have this one, blue. We're going to make this, I guess, green, pink, and red. So the blue has to be one of these two. We don't know about this. 3 has to be one of these digits here, because 3 cannot be here. 9 cannot be here, so 9 has to be one of these, and it has to be here. Obviously, because it's the largest digit. That means 9 has to be one of these two. The remaining digits in this cage have to be 3, 4, 6, and 7. 3 cannot be here. This is either 4 and 6, and this is either 6 or 7 here. This matches here, so this 6 or 7 has to be here, and it cannot be 7. Therefore, this is 6, which matches this 6. Therefore, this is 4. This has to be a 3-7 pair. So the 6 matches here. This is 3, 4, or 7. Obviously, 7 cannot be here. 7 is one of these two. Where is the 7 in column 6? Can't be here because of the 7 in the box. Can't be here because they're all filled out, so this must be 7. Remaining digits in column 6 are 3 and 4. That leaves 1 and 9 in box 5. We have 1 and 7 in column 9 left. These digits cannot be 2, 3, 4, 5, or 8. So we have 1, 6, 7, 9. 7 cannot be either of these. 1 can never be here. This can never be 9. So 9 has to be one of these two. That's interesting, which means 9 cannot be here. This is 3, 4, 7, and 9. This is 3, 4, 6, 7. That means this is less than that, so this can't be 3. This is less than that, so this can't be 3 or 4. This is 6 or 7. This can't be 7. This can't be 7 or 6. So 6 has to be one of these two. What about these digits? So we have 1, 3, and 4 is possible. This cannot be 9 because of the 9 in that row. So this is at most 6. At most cannot be 5. It's 4 at least. Cannot be, has to be at least, this is 1 or 3. This can't be 3. This has to be 4, which forces this to be 6. That means this can't be 6. This is 7, so this can't be 7 here, which forces this to be 7. This 3, 4 pair eliminates 3 and 4 in the rest of the row. This can't be 4. This is 6. This can't be 7. This 6 eliminates 6 here, so this is 9. This can't be 6 or 9, so it's 1. This 1 eliminates 1 here, so it's 7. This is 1. 7 eliminates 1 and 7 here, so it's 6. These remaining digits are, what, 3 and 4? Remaining digits in row 2 are 1, 7, 9. 7 can't be here, so this must be 7 here. This is a 1, 9 pair. That forces this to be a 6 here. Okay. Remaining digits in row 3 are 1, 3, and 9. This can't be 1 because of the 1 in the row. Or sorry, the 1 in the column. This 1, 3, or 9 has to match that because this 7 matches here. Cannot be 1, so this can't be 1 here. This becomes a 3, 9 pair, which eliminates 3 and 9 in the rest of the row, so this is a 1. That makes this 3 or 9. That means this can't be a 3, 9 pair. This match here. So this can't be 4. That makes this a 1, 4 pair. 1 can't be here because of the 1 in the row, so this is 4. This is 1, 4 eliminates 4 here, so it's 3 and 4. 3 eliminates 3 here, so it's 9 and 3. This must be a 6, 7 pair. This can't be 6 because of the 6 in the row, so it's 7, 6. 1 eliminates 1 here, so it's 9, 1. 9 eliminates 9 here, so it's 1, 9. Remaining digits in row 4 are 6 and 7. 6 can't be here because of the 6 in the column, so this is 7. 6, 7 eliminates 7 here, so it's 3, 7. This is the last digit, it's 9. This has to be a 4, 3 pair, so this is 3 and this is 4. This 3 eliminates 3 here, so that's 9, which makes that 3. 9 eliminates 9 here, so it's 3. This can't be 3, so this is 4, which makes this 3, which makes that 4, which makes that 3, which makes that 4. Therefore, this is a 9. And that's a solution. Yep, fairly logical, actually. It's not completely straightforward, but if you think about it enough, about how like the killer cages work, or the non-repeating within cages, these are not really killer cages, I guess. But the non, I guess, well, I think killer cages. I don't know actually why they're called killer cages, but my suspicion is because that they kill other duplicates, right? So that means they should be killer cages, right? Anyways, it's just using the logic of that the killer cages specifically have to have unique digits. You cannot have repeats within them. And it used it very well, actually. So basically, like, for example, these two digits, where were they in row 8? They had to be these two digits. So they matched those. Therefore, these two digits could not match these two. Therefore, they had to match these two. So very unique. This one could not be any of these. Could not be this one because it saw that one, so it had to match one of these. So you always had sort of things that basically matched other things. And then you realized, oh, these must match these, right? Because this digit, so whatever this digit was, matched one of these two. This digit matched one of these two. These two digits, this digit could not be here. And since this matched one of these two, it couldn't be here. So these two had to be here specifically. And so there you always basically ran into that pattern. And then you found out, hey, this is F and G. Well, obviously this couldn't be F or G. So this had to be A. And you worked that way. Very cool. Very cool use of the cages and those geometries. I'll have to think about that actually in the future to see like what those cage geometries have. Very nice setting of the puzzle, and yeah, it was definitely worth the solve. And I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.